So these are slightly harder linear equations with fractions in them. So if we look at our first question, we've got 2/3 x equals 12. Now that means 2/3 times x equals 12 because we've got our invisible sign there. So I'm going to write that out. 2/3 times x. And I'm going to turn x into a fraction by putting it over 1 equals 12. Now, I know that to times fractions together, I do the numerator times numerator. So I'm going to get 2x over denominator times the denominator. So that's over 3. And that equals 12. Now, I want to get x on its own, but I'm currently dividing my 2x by 3. So that's the first thing I need to get rid of. And how do I get rid of divide by 3? I multiply by 3. And if I do that to both sides, I'm going to get 3 times 2x over 3 equals 12 times 3. So we know that this multiply by 3 and the divide by 3 cancel to leave me with 2x. And 12 times 3 is 36. Now, I haven't got my x on its own yet, so I've got another step. I'm currently multiplying by 2, so to get rid of that multiply by 2, I do the inverse, which is divide by 2. And doing that to both sides gives me, I'll just do it in one step now, so 2x divided by 2, 2 divided by 2 gives me 1, so I'm just left with my x. And then 36 divided by 2 will give me 18. And that's my solution. But I can put that into the rearranging triangle. And remember, in our triangle, we have times for that line, and this line is divide. So I'm going to go to this part of my example, and the thing in the numerator is 2x. And then we've got 3, and 2x divided by 3 gives me 12. So I want to find what x is, but currently, because I've got 2x, that's going to be what I'm finding. So 2x equals, and if I cover that up, I've got 3 times 12. So that means 2x equals 36, sorry. And then I'm going to do what I did in this stage, which was divide both sides by 2, because I'm currently multiplying them by 2, to get my x on its own. So I get x equals 18. And that's the same solution. Now, if I look at this example, it's slightly different because we have an x on the bottom. So that means that I need to get my x on the top before I can work it out in any way. So if I'm going to solve this algebraically, I'm currently dividing by x. How do I get rid of divide by x? Times by x. So times both sides by x. So that gives me x times 4 over x equals 5 times x. So we know that times x and divide x cancel each other out. So I'm left with 1 times 4, which is just 4. And 4 equals 5x. Now I can see that I'm multiplying x by 5. So how do I get rid of multiplying x by 5? Well, I just divide x by 5. So divide by 5 on both sides. So on this side, we're going to have 4 divided by 5. And on this side, we're going to have 5x divided by 5. So the 5 and the 5 cancel each other out. So because 4 over 5 is a fraction in its simplest form, I'm just going to leave it like that. And that is what x equals. And we might prefer to rewrite that as x equals 4 over 5, because we like to have the x on that side. Now again, I can put this into the rearranging triangle. And this is where the rearranging triangle really helps make it clear and quick. So again, I've got that line being the divide and that one being the times. So now if I look at my equation, I can see that the number on the top is going to be a 4, and it's 4 divided by x equals 5. So now all I need to do is cover up the x, so I get x equals, and you can see that because that line means divide, x equals 4 over 5. And that is our solution.
Okay, Mary, so let's have a look at this one. So solve x plus 2x equals 12. So what do you think you do first?
Okay, well, I want x on its own, so I would put x equals 12 minus 2x.
Okay, so a lot of the time we want to get x by itself, but what we want to do first is get all of these x's together. So can you see anything we can do with this? Get all these together in one place.
Oh, okay, it's 3x, isn't it?
Yeah,
so
absolutely.
3x equals 12. Oh, and so x equals 4.
Brilliant, spot on, well done.